This is basically the story of a collision between Earth and a planet called Theia. In the very early solar system, instead of just 4 rocky inner planets, there were scores of protoplanets and countless planetesimals. The planetesimals would merge to form protoplanets, and then the protoplanets would collide and merge with other protoplanets to form large terrestrial-type planets. All these objects were jockeying for a position around the Sun, and as their orbits intersected, they would collide and merge, or collide and throw one another into the Sun, or even out of the solar system. The planets didn't even have to collide to destroy each other. Just passing close to another large planet could disturb its gravity field and knock a planet right out of orbit. One of these protoplanets, which we call Theia, formed in the exact same orbit as Earth. But it was a stable orbit. Theia formed either 60 degrees ahead or 60 degrees behind the proto-Earth. But as it grew larger, its orbit became less stable. And when Theia's mass reached 10% of Earth's mass, or approximately the size of Mars, gravitational perturbations from other planets knocked Theia out of its orbit and started its death spiral into the Earth. Initially, it was thought that Theia struck a glancing blow at a 45-degree angle, but new evidence suggests it was a direct collision between the smaller, denser, solid little planet and the larger, still molten, wet and gloopy Earth. Earth's fluid crust and mantle splashed off into space, along with a small amount of Theia's crust and mantle. This mixture of materials from the impact formed a ring of debris around the Earth, and within a few hundred years, half of this debris coalesced to form the Moon, which orbited Earth's equator. Researchers at the Japan Agency for Marine Earth Science and Technology show that an impact between a solid Theia and a molten Earth would form debris which consists of 80% of Earth and only 20% of Theia, which explains the striking similarity between Earth rocks and Moon rocks. Whilst the Moon was forming, what was happening on the Earth? The collision knocked the Earth off its axis, which resulted in its current tilt and, of course, the seasons. It also speeded up the Earth, so that immediately after the impact, Earth rotated so fast that a day and night only lasted 5 hours. We know the debris from the collision formed the Moon. We know the collision tilted the Earth. But what happened to the third actor in this drama? Where is Theia? Hardly any evidence of Theia actually exists. After all, Moon rock is essentially the same as Earth rock, so there's very little of Theia in the Moon. Since the Earth wasn't a solid, but really just a sea of hot magma, most of solid, dense little Theia sank to the center of the soft, molten, gooey Earth. Kind of like a cricket ball dropped into a vat of melted chocolate. Just hours after Theia sunk into the Earth, its iron core merged with Earth's core. This explains why Earth has a huge core that's 50% of its diameter, while the Moon has a small core that's only 20% of its diameter. But what about the rest of Theia? Where is that? Scientists at Arizona State University may have solved that mystery. They believe that 2 huge blobs of material splatted up against Earth's core may be the remains of Theia's mantle that sunk 3,000 kilometers into the Earth. The 2 blobs sit, one under Africa and the other under the Pacific Ocean. They're between 1.5 to 3.5% more dense than the rest of Earth's mantle. And the blobs are 1,000 kilometers tall and up to 3,000 kilometers wide. Lead researcher Shen Yun has calculated the blob's age, density and size, showing they exactly match predictions of Thea's age, density and size. His YouTube video on Thea, LLSVPs by Shen Yun is fascinating and well worth watching this weekend. The giant impact hypothesis explains how the moon was formed and many of its mysteries. It explains the relatively small iron core of the moon, why moon rocks have a nearly identical signature to Earth rocks. It also explains why Earth is tilted and why we have seasons, and why Earth's spin and the moon's orbit have a similar orientation. It even explains the mysterious blobs that hug Earth's core.